Hello, and thank you for, I'm loud in here. Thank you for coming to hear my talk. I'm honored by your presence. My name is Randy Barlow. I work on the Fedora engineering team with Paul Fields and a bunch of incredible engineers. It's a thrilling place to be. And today I'm going to talk to you about our plans for getting our containers that we're making to you. I'm going to begin the talk by describing the challenges we face with getting our containers out to the world. And then I'm going to present to you a plan that we think of as being our immediate short-term solution. We have a very short time frame to achieve our goals, and so we're going to take some shortcuts. And lastly, I'm going to talk about the future, the crystal ball, so to speak. I'm going to try to predict the future, which is very hard to do. So the problem, Fedora, as if you've been in this conference very much, you probably haven't made it very far without hearing about all the containers that Fedora wants to distribute. For the record, Flatpaks may have some connection to containers too, so we aren't just talking about containers. We may be also thinking about Flatpaks a little bit here. And so we want to distribute those to our users, and we have a lot of them. And our users aren't in one place, they're all over the globe. So we need a solution that will scale for a large number of people that are distributed around the planet. And I had a note here that so far we don't have any requirements to ship our containers beyond the solar system, but maybe in the crystal ball we can think about some ideas for that. I wanted to make a note also that I'm open to questions throughout the talk, so if anything strikes you, you can ask a question. You don't have to wait till the end. So for the next few minutes, I'm going to talk through some ideas we considered. I joined the Fedora engineering team in June of last summer, and when I joined the team, there had been some ruminations about this problem, and maybe more some ideas, some plans, some thoughts. And so I'm going to start by talking about the initial plan that we had considered, which was to use Pulp. And Pulp is the project that I worked on for the approximately 4.5 years prior to joining this team. And I think it maybe helps me sneak into the door a little bit to be here because I had the experience with Pulp, and in particular, I wrote Pulp's Docker plugin to distribute its containers. So when I joined the team, Adam Miller who's actually giving a talk right now in another room, he had developed this plan to use Pulp to solve this problem for Fedora. So we sat down and talked about this quite a lot. One of the things that I came to realize was that the plan was to use Pulp to generate the artifacts that we would put into our mirror network. And one of the things that seemed a little bit challenging about that for us was that we'd be using a relatively complex project to essentially create some large files onto a file system. They're called blobs. They're the images for the container, and we are going to then put those into our mirror network. But it seems like using a crane to crush a fly, so to speak. That's an idiom that means a very powerful solution to do something that's small. So I started talking with Adam Miller, and I suggested that we could write a small tool that simply extracts these files that we want so that we could put them into our mirror network. So we started iterating on our next idea, which was to create a small tool that can talk to our internal build container registry, extract these large files, write them into a file system in a way that's suitable for mirror list and mirror manager to consume, and then we would have our worldwide mirror network copy these files down, and then what? So we started thinking about this problem. There's a lot of things that needed to change here. We would need to make contributions to mirror list. If you're not familiar with mirror list, when you type DNF upgrade, your DNF client talks to mirrorlist, and mirrorlist hands you back a list of places where you can get repository metadata, and then your client picks one of those, which is hopefully near you geographically, and then it will extract the repo metadata and retrieve whatever files you're looking for. So we had to alter mirrorlist to be container aware. In addition, there's another service that you may not be aware of called Mirror Manager. Mirror Manager is the Mirror admin side of things. So mirrorless is for user-facing. Mirror Manager's job is to tell the mirrors about what updates are available, and it gives them some options about what they want to sync down. So we had to also update Mirror Manager to be container aware. And we would also have to make some changes with our build system and sort of integrate it with these other systems. So there was a lot of pieces to touch here, and it's complicated. As we started thinking about this, we realized that it was going to take a long time to achieve this system. It would work well, but it would take a long time to get there. Additionally, there's one more challenge. We analyzed the notary system, which is a container signing system, and we decided that it was a bit more complex than we want to use, and it wouldn't integrate well with our existing signing solutions. So we needed a way to serve these containers and manifest to our users that was safe, so that they can guarantee that the files they're downloading from the mirror actually came from the Fedora project and haven't been man-in-the-middle attacked by anyone along the way. So we decided to consider another approach. And this was going to be a small Flask app that we named Fegistry. And we considered doing this project with OpenShift dedicated, where we could store our large files in OpenShift dedicated, but serve the manifests and initial API calls from Fegistry. Fegistry's job is to answer the container pull call. So when someone wants to retrieve a container, they will speak with Fegistry, and they'll say hello, and Fegistry will say hello, and then they'll say, I would like a manifest for the Fedora container, and then Fegistry says, here you go. And then when the client asks for the blobs next, it gets a 302 redirect into OpenShift dedicated. There was actually a really cool patch I found that Runcom created that would allow us to inject URLs into the manifest such that the client would never come back to Fegistry to ask for the blob, which would save a step. It also allows you to give a list of places they can find it instead of a single place, which is the problem of a 302, so that if any one of them responds with a 404, they just iterate the list until they find the container. So that seemed pretty cool. However, we have an incredible sysadmin in Fedora, and I was talking with him about this problem. Actually, what really happened is I wrote a pull request, and he reviewed it, and he didn't like it. But this is good, right? This is open source, right? So I'm proposing a change to Fegistry, and he comes in and says, why are you doing this? My change was to add support for the 302 redirects and some caching. And he said, why don't we use Varnish, and we can use Varnish to do some caching for the responses, and we can use just HTTPD rules for 302 redirects. And I responded that we wanted to have a Fed message consumer inside Fegistry that would know when to invalidate the cache. And then once again, our amazing sysadmin, this is Patrick Altovich, which I've mispronounced surely. He responded that we actually had a solution in place to do cache invalidation in response to Fed messages, which is awesome. So we decided to kill Fegistry. It only lived for about 3 days. It was a sad thing. I want to make a side note here that this is something that you might encounter while you're writing software or doing any kind of technical work, that you may have something that you're investing in, and even if you only put 3 days into it, you feel passionate about it. And when someone comes and says on your pull request, let's not do this at all, this entire project, let's just kill it, it's it's a tough thing to hear. But the thing is, you have to be able to override, look past your feelings and analyze, is this what's best for Fedora? Is this what's best for our users? And it was. So we made the decision to retire Fedistry. By the way, it was in rawhide for about a week. It's retired. And I was hoping I would get a badge for that because I wanted your project was the shortest ever project in Fedora badge, but I didn't. There's no badge for that. Maybe I should submit an idea. So now I'm going to talk about what we are going to do in the short term, and I've actually hinted at it quite a lot. So we're planning to run the atomic registry in our Phoenix data center. The atomic registry, the reason we're going to use the atomic registry is it's difficult to keep up with the API changes and manifest changes, and I've had a lot of experience chasing these things, and every time you spend a long time writing all your code, by the time you submit your pull request and your coworker tells you that you forgot all these things, there's a new blog post and they changed it. There's V3 now and schema 10, and everything you wrote is no good anymore, and you have to throw it all away and make a new project. So in order to avoid that problem, we're going to use the atomic registry and let someone else solve that problem for us. So this is going to be in our Phoenix data center. And we're going to use Varnish on top of that to handle requests. Now, one thing that's awesome about and I don't have a graph for this, but one thing that's very awesome about our Varnish system is that it is a worldwide network of Varnish servers. They're somewhere out there. There's probably one nearby here. And so what this means is when you ask for a container, you will very likely not be talking to the Phoenix data center unless it's not in cache. You're very likely going to receive a response from a caching proxy server near you. So this should be a quick interaction. But what's more, you won't be the data center will be protected from serving any of the large files, the blobs, because those will come from OpenShift dedicated, where we will run another atomic registry. The reason we are not just using OpenShift dedicated, the reason we have one in our data center is we want to serve the manifest over TLS because we will not have signatures for our containers for most clients. And in order to provide safety, we will serve the manifest to you over TLS, and the manifest references the containers by hash, typically a SHA-256 hash. And then when your client asks for the blob from OpenShift dedicated, which runs in Amazon, you don't have to worry about whether the container image has been tampered with because we will check the checksum and make sure it's correct. I want to say a side note here that we also will have many users in Fedora who use the atomic client, and we do have a signature solution for atomic's pull command. And so we will be signing for that client. But Fedora really wants to support the idea of non-Fedora users pulling our containers and using them. So we want to think about Windows users even, actually, because they can run containers, and maybe they would like to use our containers that we're making. So we want it to be safe when they ask for a container from us. So we don't want to rely on the atomic signature being the only way we provide safety. So that's the motivation for running two of these and using one just to serve the API and the other to serve the files. And Loopable is in the picture here. This is a project that Adam Miller made that's very cool. It listens on the Fed message bus, and in response to any messages, it can be configured to run a playbook for us. So we can use Loopable to listen to our build system and know when new containers are out. It can push them into OpenShift dedicated for us and push it into our Phoenix data center so that everything happens automatically. And you just type koji build and everything just goes where it goes. So that's the role of Loopable in the solution. I'm going to show you a picture of sort of how the API is going to work. I actually skipped a few steps here. So after the client says hello to our Phoenix data center, is this the laser? Okay. The Phoenix data center, so this is our atomic registry inside our Phoenix data center. It runs behind HTTPD, which protects it from, this is going to send 302 redirects. We have our caching proxy server, which there's one in Phoenix too. I actually didn't draw this, but as I said, there's actually one of these near you as well. So you may not ever even speak to this data center. But the client will ask for a manifest over TLS. The data center will return a manifest over TLS. And now, as I said, this manifest has the hashes of all the blobs inside it, so you can be sure whether you're getting the correct blobs or not. The next step is that the client will, an unpatched client will then ask the data center for the blobs. These are the large files. The data center is going to say, no, you can't have that, but you can get it from someone else. So he'll send a 302 redirect. And then lastly, the client will go to our OpenShift dedicated registry and ask for the blob, and the blob will be returned. Are there any questions at this point?
Yes. So when you are putting the atom-based in like the one Unix data center, then there you are putting only the layer details. So how you are getting those details in OpenShift dedicated? Means how are we pushing the layers then separately?
So the question is, how are we putting the blobs? Whoops. What have I done? The question was, how are we're putting blobs in our Phoenix data center, but we're also putting them into OpenShift dedicated, and the question is, how are we accomplishing that? Is that?
My question is, are we putting them separately? Like the OpenShift dedicated is not having the layer details or the checksum details?
Oh, they both actually have a complete copy of both codes. So the internal registry has everything. It has the manifests. It actually does have the blobs. And the one in OpenShift dedicated also has all the metadata and the blobs. However, we don't want users to default to coming here because we cannot guarantee as the Fedora project that these images have not been tampered with, given that they don't run in our data center. So the only reason we're putting the data in both is for simplicity. We don't want to write our own custom project. We want to use upstream projects. The cost here is that we will be using a lot more storage in our data center. That's a downside to this plan. And likewise, the OpenShift dedicated doesn't really need to have the manifests, but they're relatively small. The big deal with there is going to be the storage and the bandwidth. So our thinking is that keeping this solution simple allows us to deliver more quickly, and we can solve those problems later, and we will. Any other questions about? Okay. So that's what we're going to do, and we're planning to launch that solution in mere weeks. We are very close to being done there. So once we're done with that solution, we will have to do some work to bolster it a little bit to make our data center solution highly available and scalable. So for the next few months, we're going to be working on doing things like writing standard operating procedures for our sysadmins, and we're going to write a lot of documentation, and we're actually going to deploy into more than one data center. Phoenix will actually, in the end, not be our only data center that has the in-data center manifests, so that we can fail over live. We anticipate to have all of that done. So the goal for the initial launch is just Fedora Alpha, Fedora 26 Alpha, so that's next month. We want to be highly available for the beta freeze, so we have a few months to work on those things. After we finish that, we can start thinking about what do we want to do in the long term. One of the problems is the storing all of our blobs in duplicate like this will cost us money. We also will be paying money to use the OpenShift dedicated system, and so we're trying. Being that we're the Fedora project, we don't have the large budgets that some other awesome companies have, where they have this incredible CDN. And in fact, it has been estimated that in order for Fedora just to mirror our RPMs and something like a CDN would cost about $2.3 million a year. And Paul, my manager, just made a scary face. That's a lot of money, and so Fedora has traditionally always used our mirror network. We have a worldwide volunteer mirror network, and I hinted earlier that we had been looking at a solution to use them. And so one of the things we would like to do long term is to consider other blob storage solutions. One idea could be to do all that work I talked about of getting our manifests, keeping our manifests stored from our data center, but keeping those blobs on our mirror network, which would involve all those changes to mirror manager and mirror admin, mirror list. One thing that's nice about our short-term solution is that the in data center in data center registries we'll be running will still be useful for our mirror network for the same reasons. A caveat to mention here is that our mirrors typically do not want to run software that we ask them to run. They really just want to serve files out. And this is a problem for the trust. Since we don't have signatures, we need to run the container API in our own data center over TLS. So it's going to be advantageous that we have this in data center deployment for the long-term future, I think. So we need to think of new places that we can store our large blob files. We had also considered using perhaps something like Docker Hub, but Docker Hub actually does not have terms of service the last time I looked, which was in December. None at all. When you make an account, you're not asked to agree to anything. Question.
Why don't you require people to use TLS? So why don't you require all the mirror hubs to use HTTPS to serve files? Because now, let's say, it's very easy to get a certificate. On the other hand, a lot of attacks, like recent attacks on the Debian mirrors, where it's Debian package manager, were only possible because they served files over HTTP and just used GPG to verify the signatures. So just get rid of HTTP. Just go HTTPS. So why don't you go that way? Help all your mirrors, all people that host mirrors at home or at the company to use HTTPS.
So the question to summarize is, why do we not require our mirrors to serve all of our files over HTTPS so that we don't have to rely on signatures?
Do both.
And do both. Well, if you recall, we don't have signatures for our containers when they are pulled with every client that's available out there, because we will not be using the notary service. So we need some way to assign trust to the files you're downloading. And even if you speak to a mirror over HTTPS, this indicates that you trust the mirror, not that you trust the Fedora project. In other words, there's no way for you to know that the mirror has not tampered with the files at all, and that they really came from the Fedora project. And that's a really important thing to us, is asking the question, who do you trust? Perhaps you have a mirror that you trust, maybe you run it yourself, but we don't want each of our users to have to think about this, about trust on each mirror, and you have to trust the Fedora project. So if we serve our manifest over TLS out of our data center, then there's a verification that you really got that digest from the Fedora project. And then you can go to any mirror, and as long as the file you download matches the checksum, you can know for sure that it came from the Fedora project and has not been tampered with. Although I would say it's still good to speak to the mirror over TLS just for privacy and as sort of like a second layer of defense.
So you said that the notary was more complex than you wanted to use for signing. Is there a conversation about signing for more than just atomic and not using notary?
So the question is essentially, is there a conversation to be had about the notary service's complexity and whether we want to try to offer signing for more than our atomic client? I actually am not an expert in this area, so I don't know that I can tell you the full details. Our security chief, our security officer, I like to call him chief, Patrick Altovich, who I've now pronounced 4 times incorrectly today for sure, he analyzed the notary service and determined that it was not ideal for Fedora to use it. I really cannot tell you the details. I got him to explain to me once, and Patrick knows a lot of things that I do not know. I would, if you're interested in asking that question, I think we could have a discussion perhaps on Fedora Devel, and I'm sure he would participate in such a discussion and probably give us an amazing answer. So I don't know the details. I just know that he did closely examine the solution and rejected it for Fedora. The comment was, tell him to come up with something else, which I am very much in favor of. Yeah, that would be helpful if we had something like this. And to reiterate, users who use the Atomic CLI, which is going to be integral in the future Fedora operating system, those users are going to be getting a GPG signature on these things, so they don't suffer from a lot of the problems we're describing here. But one of our main goals was to think about more than just our own current users. We want to think about trying to draw windows from sorry, what did I just say? Trying to draw users from Windows or other Linux distributions. So we want to make sure that they are also getting a guaranteed safe experience from our containers and are not being attacked in any way. Any other questions?
Sorry, do we know if the mirror networks are eager to serve this kind of content?
Oh, I completely forgot to talk about that. Actually, that was something I meant to say, and that's good that you brought that up. So the question is, are our mirrors eager to serve these files? And this is actually one of the biggest problems and I can't believe I forgot to mention this. So one of the challenges with containers and many of these new formats is that they are doing a lot of bundling. In addition to bundling, they use these layers. So you have typically a base layer, which has your core things like glibc in it. And then you've got your application layer on top that might have the program you want to run, like perhaps HTTPD. If you think about this causes a distribution problem for the Fedora project because these things generate a huge amount of data. Every time the base layer changes, we will need to build every single container we have in the whole project again. So if there's a glibc security update, instead of updating glibc, the RPM, and having one file that changed, we will now change every container we have. And this means that you have however many containers Fedora has times hundreds of megabytes that we now need to send out to our mirror network. And this could happen a few times a week. And our RPMs are already quite a lot of data, but we're talking about making each container is also a lot larger than the RPMs that make it up because there's so much duplication. So suppose that I've got a container and you have a container, and we both depend on Python Django. Your container has Python Django and my container has Python Django, but there's no deduplication. So we've got that twice. But we know that's not twice. There's other people using that as well. So that particular package will be in quite a few of these things. So every time we do a rebuild, we could be talking about 10 terabytes that our mirrors need to sync down. And even with very fast data links, that's a lot of data. And you have to think about storage as well. We often, I laugh sometimes, I talk to, as a developer, I'll sometimes say, well, you can get a big hard drive for $100. But that's because I've got a consumer hard drive in my computer. It's not a data center hard drive. Data center storage costs a lot more than you'd think. It can be surprisingly expensive. So our mirrors are volunteering to do something that costs them a lot of money, which is awesome. But we can't ask too much of them. So that's one of the challenges, I think, of potentially a long-term solution of putting the blobs in the mirrors is we may not see very much participation from the mirrors in syncing that content. We have had some discussions on the mirror. There's a mirror admin mailing list. We did try to put out some feelers on the list to ask, like, hey, if we did this, what would happen? And there was a lot of questions from the various admins about how much data we were talking about. And those questions are very hard for us to answer. But the truth is we're talking about a lot of data, and it sounded like there would be a lot of concern from them about whether the places they work and they host this stuff would be willing to pay for both the bandwidth, the storage. I guess that's just the two things, the bandwidth and the storage. So that's a really big problem. It may be that does not work for us long term, and we'll have to think of something else. We also did look at key.io or quay.io. I have no idea the right way to pronounce it. We would need to establish proper terms of service, but that may be a potential option for us. And maybe there's something else I don't know of that you know. So if
what OS tree, would that be a way to reduce the amount of data that needs to be transferred around?
The OS trees?
Yeah, because they normally to do the change right instead of the whole block.
Mm-hmm. So the question is, would OS trees be another way we could distribute these to reduce the amount of data? That's a good solution, but OS trees actually have the opposite problem from containers when it comes to mirroring. We actually did, in the past, put OS trees into our mirror, and we got some, I actually wasn't around for this, so I did not receive these emails, but I heard that there were some consternation. The problem with OS trees is instead of making huge files, which is the problem with containers, they make lots of little files. and the mirrors actually sync with rsync. And so they would spend an entire day doing a sync, and then we've already updated it again. And
There's no chance asking them to sync with OS3 themselves instead of using rsync?
so can we use them? Can we ask the mirror admins to use OS3 instead of rsync? One of the problems that we've had with the mirrors, sort of a social problem, not a technical problem, is that they typically do not want to run software we ask them to run inside their data center. They want to have a simple HTTPD server serving a file system, and then they like to use rsync. And this is sort of the way it's always been done. And if you keep in mind that many of these mirrors also mirror other distributions, so they want something that will just work and be easy, because after all, they're volunteering and they're being very generous to us, and we can't ask very much of them. We can't ask them to run our software, for example.
Also, we can't guarantee we can't guarantee there's a IT architecture in place that will even run this.
A comment was that we can't guarantee that there's an infrastructure in place that can even run OS3 at all. So we could offer options, though. This has been a discussion inside release engineering that we could ask mirrors to volunteer to do things like that. So we could put out, say, hey, we will, you can rsync these files, but it has some problems. If you're willing to run OS3, consider that. We could do this. And we may see some participation. But historically, it seems that the participation levels when we ask for things like that is actually quite low. So that's one of the challenges there. Any other questions? 10 minutes. All right. I'm actually near the end of my talk. So in summary, we talked about the challenges, and I forgot to talk about the mirrors and the big files problem, but so I talked about the challenges out of order. But we talked about some challenges. I talked to you about some of the solutions that were considered both before I joined this project and since I've joined the project. I talked about our short-term plan to run an atomic registry inside our data center and an OpenShift dedicated, just to get us going, because we need to have this live in a few weeks, which makes Amanda happy. And we want to keep Amanda happy. And then we talked about some long-term ideas. The long-term ideas are not in any way set in stone. These are just things we're thinking through. And if you have ideas that we haven't talked about, I would love to hear about them. Because we're kind of out of ideas. So, Paul.
Unfortunately, I don't have an idea because I'm a manager. So is there, can you to some extent address how CentOS content plays into this idea at all?
Oh, yes.
Collaboration there?
That's right. So we have been in talks with the CentOS project to find some ways to, we're looking for ways that we can collaborate on this problem. We have talked with them a few times. There's this high-level idea that we want to collaborate, and that sounds awesome, because why would you not want to collaborate? When we work together, we accomplish more than when we work apart. But one of the things that's been difficult for us to identify up to this point is what are the exact integration points that we can collaborate on? Where do we draw the boundaries? There are some suggestions that we could actually share a registry deployment so that one registry would have Fedora containers and CentOS containers. There are options to share the technology, to share the way we deploy. There's all kinds of hybrid ideas we've talked about. We've considered even using 302 redirects in our registry, so when we see people asking for CentOS containers, we say, I don't know where I don't have CentOS containers, but I know they're over there, so I'll send you there, and vice versa. So there's actually a lot of discussion left to be had, and in fact, we're planning on talking about that in an ambiguous time over this conference, like a hallway track. Yeah, perhaps today, perhaps tomorrow. We'll talk. So that's an ongoing question: is what are the details about the levels at which we can collaborate together to share and work together to create something bigger and better. So yeah, it's kind of a fuzzy answer. We're at a fuzzy place. Any other questions? So the question is, how do we manage authentication and authorization on the registry? So because this is an open source project, and as it's sent to us, we actually are not going to require our users to authenticate when doing a container pull from us. Much like with DNF, we don't require you to authenticate to do package updates or installations. We do plan to use authentication and authorization on write operations, of course. And we plan to just use HTTPD to protect the particular API calls that are involved in pushing containers to the registry, so that it's only allowed from our own infrastructure, which we use Kerberos all internally. So it'll be you'll have to have a what's the term?
TGT.
Yeah, it's actually, what is it?
Proper ticket.
Yeah, but I was thinking I forget the name of when you have a server that has a Kerberos. Yeah, service principal. So basically only our servers are going to be able to push into the container registry. No users will be able to do this. And it'll be protected by the server. Any other questions? No? Okay. Actually, I should have put this slide up. So that's all I have to talk about, unless there are further questions.
Maybe one more. Isn't it an occasion for improving all the tools regarding the mirrorless? I mean, so that you would propose some tools which would offer, for example, the duplication, which offer multicasting, and then we would also propose some pull requests for the client side tools which would consume or use these new features, so that everybody would look at this as an improvement, step forward, and then it would be more acceptable for them to serve those big blobs.
So one of the questions is, do we have an opportunity here to make contributions to our mirror list and mirror manager projects, so that they can do things like deduplicate the blocks in the large files and make it easier for our admins to our mirror network to consume. If we were to use the mirror manager to distribute our blobs, we would have to make contributions to it. As it is, it's very oriented around Yum and DNF repositories. So when we were considering this, that was very much the plan, was to get involved in that community and make contributions there. One of the problems with the deduplication, so we could deduplicate some of the data in Mirror Manager itself, perhaps, but if you recall, one of the challenges is that the blob files need to be downloaded by the mirrors. They need to retrieve these files, and they don't wish to do anything other than rsync. And so that's the trouble is, though rsync does a lot of block sort of deduplication operations and things, the amount of data we're asking them to serve is still quite large. We do have the opportunity to distribute the base image one time, so that's a point of deduplication. So we can have that hard linked so that it's only served one time to all the mirrors. But the deduplication I was referring to is actually mostly in the layers on top. Everyone that has Django is going to get Django in it again and again, and it's very difficult to deduplicate that without using a fancy file system or other things. But rsync will not do that for us, unfortunately. Any other questions or ideas? Verbal pull requests? Okay, well, thank you for coming so much. I really appreciated you all, and thank you for listening.